Hey, hey.
Okay, cool. So hi, everyone. Thank you for joining us. I want this talk also to be very interactive, so pay attention, and we're going to hack a live app today. So without further ado, my name is Liran Tal. I'm a developer advocate at Sneak, where we build developer-friendly security tools to help empower developers, just build using open source in a secure way. I'm also kind of involved in the, this is like the Node ecosystem security working group. It got a name change. OWASP and some other projects, some other like work around security and web, Node.js and all of those. If you want to ask or join any of this, just reach out. I'm on Twitter or just like, the regular Facebook stuff on the local communities. And with that, let's get this out of the way and, thank open source because it is awesome, right? We have Firebase, open source tools, Angular, React, SES, all of those things. This is amazing. Node, JavaScript, all of this. And I don't need to tell all of you here that open source is growing because, it is, right? I need to update this slide like every day. This is the problem with NPM, right? It's 1.4. Then like a week later, it's 1.5 million, packages today. So yeah, it's growing. Everything else is growing. It's growing. So open source is growing while we do NPM install. That's like how incredible it's growing. So yeah, it is. But really, the question is, like, how much do we really know about the dependencies that we use? And yeah, this is going to be a security talk, but I do want to put some security research articles that I've been reading and have been, I think, super interesting and insightful in terms of what we can learn from them. So I think firing off something kind of like fresh, which I've digged up. Interestingly, we are not the only people asking about, this question of open source supply chain security. Basically, all the open source that we're using and what are the involved risks of using it. So this is the, what is this? This is like the Cyberspace Solarium Commission, blah, 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 whatever. But actually published this in October 2020. So not so long ago. And it was calling out all of this, right? So it's like crying about this thing and, raising the importance of open source supply chain security concerns. And, specifically, they have I've got several quotes out of this, but they have called out that they want to build a center for open source software security to test for vulnerabilities in open source software repositories, which serve as the foundation for most of today's software, which of course we can't deny, right? Because do you remember those times when we used to open the IDE to file new projects and start off from scratch? Yeah, it was nice days, but we don't do that today, right? We do npx create React app or whatever. We build the app from that point on with open source packages. So think about it for a second, because my next slide is going to show you some interesting stats. But another research article, security article I've read from a previous research was looking at the difference between NPM and PyPI, and it called out what is the average nested levels of dependencies it adds for you when you do the average NPM install. So what is it, like 1 packages, 2 packages, what packages go in? So maybe you play that numbers in your head, but that research article says, right, on average, you're basically going to be pulling in 4 levels deep of dependencies when you're running that NPM install, right? I bet, none of us is going to go, I don't know about you, but I'm not going to go and code review every NPM package I'm going to install. Definitely not all of the dependencies it's going to install. So, that's the world we live at. The other thing that this security research, academic paper thing have called out was this is part of the same paper. So if you want to read it, it's has some nice, interesting highlights. The other thing was they called something wanted to figure out what is the average, or not average, but what is the amount of packages that could be considered abandoned in the NPM and PyPI repository. 61% of packages would have been abandoned on NPM. That's back to I think 2019 when they ran that research. So still about 1 million packages, more or less on NPM. So think about it, more than half of the registry. And you could counter argument this and say, well, maybe the package has reached maturity or whatever. So how do they even decide what is an abandoned package? So they came up with this category that says if the package did not receive a release in the last 12 months, we would flag it as abandoned package. So 61% of packages on NPM did not receive a release in the prior 12 months when they ran this research. And like I said, right, you could say, reach maturity, feature complete, whatever you want to say, right? Problem is, we got reminded of the event stream incident, which Mark Miller on his, in the first talk here on this meetup, was actually referring to, right? This, to my opinion, probably one of the most significant attacks or, incidents, security incidents, if you'd like, on NPM on JavaScript that we've seen. Because walking basically like very shortly on since we don't have a lot of time here and I do want to do some live hacking, but walking very shortly on what happened, right? So event stream is a package owned by Dominic Tarr, member of the open source community and NPM, and this specific package existed on NPM since like 2011, so like almost a decade. I did not hear about it before. I'm pretty sure you did not either, because it's not really used as like, the main direct package that you'll add to package.json, but it will probably be used by things like, React, maybe like Webpack, part of like this, the downstream dependencies. So it practically did not receive any release in the last 2 years. But suddenly, a person shows up and says on the GitHub repository, hey, I want to help. They open an issue, they want to help. Of course, they follow up with some pull requests, more pull requests and all of those things. Then they eventually go ahead and create a pull request that adds a dependency called FatMapStream into, event stream's own package tree, because why not? I mean, this is NPM and it's modular and it's JavaScript. Why would I not, reuse that in my other projects as well? So, this went well, and they did receive, that kind of contribution merging in. And at that point of time, Dominic also said, he's a person of, doing a lot of open source work, and he's not short of doing open source. So I has like, maintain like 400 or whatever other modules on NPM. So, why not let this person who has kindly stepped in to help me, work on open source, manage this project? So kind of like this is how they socially engineer their way into event stream, a package that gets downloaded, millions of times a week, and being able now to influence this entire dependency tree by basically adding a new dependency that they control. Of course, when they added it, it was just fine. Didn't really do anything except what it was supposed to do, except, a version later, it did something more malicious. It actually targeted Bitcoin wallet application called Copay, but not really the Bitcoin wallet application. It actually targeted us, right, developers using it, because they understood how the build process works, and the fact that event stream is part of it. That's why it actually targeted event stream to begin with. And since that Copay app is working, being developed out in the open, in the public, they could figure out all of those things, just doing a little bit of like open source intelligence and figuring out how things work. So yeah, this kind of like went unnoticed for like 3 months, ended up with several versions of Copay being deployed, having the malware. I've seen some people, basically some companies that I know about, that are like, until today still have, remnants, right? So it has like, they have like a FlatMapStream or event stream basically as part of their dependency tree in some projects. So I don't know if that's going to be for something useful, hopefully not, but that's the truth. So here's a mental exercise, right? You imagine you're building an application, Node.js or whatever, or something maybe else. But your mental image is really that, end diagram, right? Is that end blob, your app. But what I'm really kind of like advocating here and trying to bring the awareness of is, well, the app that you write is actually a lot larger, right? We bring all of those dependencies that help us, build what we need, but our code is like, usually, a small percentage of that, and that's okay. We're using open source, but we should be aware of all of those things happening so we can be ready to mitigate them. We can be ready in the way that we need to, watch out for them, monitor them, whatever, all of those things, fix them, rush with upgrades, whatever we need. So one of those things that make it really hard is the fact that security vulnerabilities happen in open source packages very differently in the way that they manifest between different ecosystems. So what this basically means is, this is part of the state of open source security research that Snyk annually puts out there, is the fact that in NPM, for example, right, the majority of the times we find vulnerabilities for users using Snyk, it's in the indirect packages. Right, so it means if you're basically looking at all the change logs and announcements and code reviewing all of your direct dependencies, this is great. But most of the time, we'll find vulnerabilities in those indirect vulnerabilities, indirect packages, which you should be aware of. And you see that it differs between different ecosystems. And it's an interesting, I would say, a question or so to figure out, why is it, which I can kind of like, stipulate, but we'll skip that. So, there are different kind of vulnerabilities and incidents that we should be aware of. My favorite kinds of things to talk about are the malicious packages, because they are kind of like, the juicy, interesting, stories that we can learn from. For example, what could go wrong with installing get cookies or any of these other packages here. And by the way, there've been like, I shall really update this slide. There's like 2019 and 2020 related, also 2021 malicious packages incidents, but we'll focus on get cookies specifically. So if you wanted to say use and parse your HTTP headers, cookie data, or whatever, manipulate it, read it, write it, whatever, you might be willing to install get cookies, which is a package that kind of does that. It does, but it does a little bit more, maybe a lot more. It's basically nothing less than a command and control backdoor that once you installed it, it exposes this through this express middleware that allows remote code execution and injection to any Express app that bundles this and uses this. And how does it do it? So there are like a proof of concepts of these codes, remnants out there, just because people try to keep track of what was going on there. But basically, what happens is it has it serves out three different commands for an attacker to kind of use this. One of them is clearing the buffer, then loading data into the buffer, which is JavaScript code that we want to do there, and of course, lastly, running this code, executing it on Node, which is easily done at the end. But of course, to really push this in, we can hide it in several layers, which is what they did. They actually added several levels or layers of dependencies to hide this malicious package. But at the end, who's going to install HTTP fetch cookies, right? If it has 0 downloads or 10 downloads or whatever, just bots downloading it over the internet is tens or something. So let's find the more interesting story here. Maybe let's try and compromise mail parser that has 500,000 downloads a month. Get HTTP fetch cookies as part of that dependency tree, and of course the entire dependency tree kind of gets all of the downloads and all of this. And yes, there we go. We have tons of downloads. And now the next time that I'm going to go into npm.js or whatever to search for HTTP fetch cookies, and I have something that gets downloaded 500,000 times, now HTTP fetch cookies or a library called express cookies doesn't sound so bad. Maybe I'll use it. It's at least 500,000 users other that are using it. So why not? But all of those stories are, they usually, don't affect us. And, even if you had installed the malicious version of EventStream, which is, by the way, the EventStream is not a malicious package. That's just a version of it that got, been malicious because of the dependency tree it brought in. But, even if you installed the malicious version, again, of EventStream, nothing would have happened to you because the specific payload had targeted, a specific state and all of those things. So, those malicious stories are interesting, but they're not the real thing. And we get all of these other vulnerabilities, like SQL injection in SQL, in SQLize, or typo-rm prototype pollution that, I can, demo a lot of SQL injections related to. And they're always happening, right? This is the boring set of vulnerabilities, right? Markdown to JS6, almost 1 million weekly downloads. And the fact that you're using secure React APIs, not to use dangerously set inner HTML, hopefully, it doesn't mean that other developers or maintainers or contributors down there somewhere in that dependency tree or graph know not to do it either. Or maybe they know, but there's a regression or whatever. So again, it doesn't mean that you're secure if you're just using React, because if you use this one, you're insecure again. So this specific version. Well, how do we go from basically the dependencies and the vulnerabilities in them to the application vulnerabilities? Because that is not always a straight line that we can draw or understand how that works. So for that, I'm going to move into an actual demo that we have. Let's see if everything working here. We'll zoom in a bit. This is a nice to-do application, which this is where I need you to add comments in the chat, which I'll monitor to have the interactive parts here. So you see there's a couple of things here, buttons, whatever. There's some input. I could say, hi, JavaScript Israel, and all of those things. And, tell me what you would try. What would you go ahead and try to basically, exploit this? What would you try to put in? So while this is not a full interactive session, which I'll accept, I'll go ahead and guide this through. So maybe I'll go ahead and try some XSS, like cross-site scripting, which I could maybe, I don't know, like inject some JavaScript here. So things as simple as this, right? Let's try this out. What do you think? Gonna work? Not gonna work. This app is entirely JavaScript. I have this var, right? Everyone is laughing right now. This is working out. This is a Node and JavaScript all the way on the front end as well. So this didn't really work. And what I had wanted to do more on this is also basically to make this support Markdown. So I could do things like hi, JSIL or something like that, and then it gets into being bold. Now the thing is, this kind of like strong type of font here didn't really happen just the way that it is. It's happened because I'm using this marked, which has several vulnerabilities here, obviously because this is potentially deliberately vulnerable application. And I wanted to add this markdown, which of course I did not write myself, so I used marked. And let me show you on using the Sneak Advisor to look up marked, and you see marked is 5 million downloads. This is a pretty big project. So it's very popular, very well maintained, all of those things. It had, interestingly, it had some security vulnerabilities, even direct ones, not just direct and high, not just direct and mediums. Just recently, it's like what is this, like March or February, just then. So well, I'm using marked because I'm not going to write my own markdown parser, so I can go ahead and do things like this. This is the JSIL website, for example. Create links, which works and probably like won't lead me anywhere, or I will not try this now. Who knows where this brings us? But this brings another interesting kind of attack vector. Like maybe I can use the alert, or like calling JavaScript via, I don't know, maybe links, right? Like, this pattern, right? Which is, by the way, vulnerable if you use React, because React doesn't, at least not the latest version, or at least not the one that I've looked at, which was pretty recently anyway, does not filter this out. So theoretically speaking, if you're putting any props or whatever values here from user input, this will get in, and that could potentially be JavaScript, colon alert, that would have created an XSS. So unless you're like not doing this and filtering that yourself, which is a good idea, that could have happened. So yeah, well, let's do something like this here. Let's do something like JavaScript alert. And what's happening? Let's see. Let's try it out. Okay, so it did not really work. It broke kind of like in a whatever broken way, which is interesting. So why did it actually not work? Because for marked, when I initialized it, I actually had to pass in this sanitize true option. So basically, I told Mark that I do want it to sanitize all of those strings. By the way, this is not a default. So if no one had told me, if I did not read the documentation or anything like that, or maybe just missed it, I would have basically used marked. And in that version, it was default to insecure because it allowed all of those things to basically work. So hopefully someone knows this, and we do have sanitization true, and that's why this doesn't work. Now, what would you have tried next? What would be the next thing that you try to maybe create, an XSS here? This doesn't really work, and we can figure out why it doesn't work, right? Like marked is open source. I can go to the GitHub repository, watch at, look at the tests, look at the code, and figure out why this doesn't work. So the reason it doesn't work is the fact that there's a regular expression that says, look for anything JavaScript, colon something, and it just fails right there. So what if I represented part of this in a different way? What if I used my knowledge on maybe the way that the browser or HTML is constructed can use things like HTML entities or something like that, right? I could use something like what is it? Is it like this? This is an HTML entity that means a colon, and entering the chats during this. It's something about injecting a script tag, and maybe this would be 41. if I remember those correctly. Let's see what happens there. So this doesn't yet happen. This does not bring us into a proper state of an XSS. And it's to no surprise. It's because we basically enabled this sanitize true, which what it did was it sanitized this as well. So the maintainers of Mark were actually very, I would say, security minded and conscious. I mean, not the default stuff, being turned off with security turned off, but at least here when, they needed to sanitize the input strings, they understood that potentially someone could bring in this kind of HTML encoding into this input. So yeah, this didn't really work. But there's actually a deeper story here of what could happen, and that is there's a regex probably checks for all of those kind of like prefixes, characters, and then numbers and signs off with this semicolon and so on. But what if I had a way to kind of like bypass the sanitization, yet the browser would kind of like add this the way it is? So what if I had put the word this here, like literally, I know this is confusing because we're all JavaScripters here, but literally the word this. And what would happen is, well, this is not a valid HTML entity. So at this point, it bypasses Mark's own validation, and that's why Mark doesn't do anything with it. But let's try it out. I'm just gonna show you. Okay, so this is why it's actually showing us and just like killing the tension here. No cliffhanger. This is an XSS in Mark. But why did it work? Right? Because anything that I'd put here, like document or whatever, would be a valid JavaScript statement if I could type for the life of me. Document. I think that's spelled correctly. What happens is while it bypasses Mark, it doesn't bypass the browser. The browser basically just says, well, I think you meant to like close this with a semicolon. The rest of that just becomes, legal legal HTML. And so this is really why this is happening. But let's talk about it for a second. What was going on with Mark? Because remember I said there was not a lot of interesting stories around open source. But specifically with open source, vulnerabilities, the regular ones that KZCV is, but some of them are interesting. Okay, some of them are intriguing in the way that they actually work. So, Marked, for example, you see it was merged. When someone opened this vulnerability specifically out in the open. So first of all, someone basically created an open source a pull request, like publicly. At this point, May 2015, everyone knew that Marked had this vulnerability. This is a POC, proof of concept. This is how you do it, right? This is an amazing PR because, whoa, there's even tests and validation. So there's like no regression. You actually fix the problem, not just say, hey, you have an XSS, deal with it. Matt Austin is a great researcher helping us basically, solve the problem here. The only problem with this whole thing is, as you remember, we're working in open source. So there is no real urgency for anyone to kind of like merge this. That's why it's like +1 vacation for a year must be nice, because the actual truth is that this only got merged and released a year later. So 4 million whatever amount of people downloading this, back like a few years when this was happening, all were actually vulnerable at that point. This was like public knowledge, and with no fix, right? No fix of how you could do it. So this is my story of Marked, and I, being conscious of the time, I see we do have a few more minutes. So I will show you another vulnerability in my app here. Let's go back to the app. There we go. Okay, so what else can we do here? There's a couple more. Let's try about. Well, how about we do not a path reversal one, but something like more interesting. Let's see if we do a backend one. We did front end. It's only fair we do some backend here. Okay, so I am using Dust.js, which is a template engine, which is, some of us use EJS, Plug, all of those things. So here's a template engine. This is the way it works. You define a view, kind of, and there's some conditionals, obviously, which allows you to do some logic. This is why we render it on the server, and then give the results to the client. So this is my simple logic. If device equals desktop, render this, otherwise render that, and this is what we're bringing back to the browser in the request. So this would be something like device equals mobile. and it should be big. And if it's anything else, basically like desktop, it's small. See, this is mobile ready already. JavaScript IL. Cool. So at this point, let's see. Dust has some vulnerabilities. Going back into what I scanned. So my version of Dust, scanned it with Sneaker, and obviously, and it has code injection. The code injection, right, with really big, score for priorities. So what should I do with this now? How does even this work in terms of what's the actual vulnerability here? So let's think about it for a second. First of all, if we think about the route of, well, how do we exploit this? Then this is user input, right? I've just showed you how this template receives user input. So device equals mobile, that's an input. And I could do several things, like maybe, I don't know, let me try to do quotes or single quotes, but looks like it's treating them okay, escaping them or whatever. So that doesn't really work anyway. What else could I do? Any ideas on the chat are good, but again, for the being conscious of time, I will move forward here. So let's see what's going on with the Dust code base. So if we go into the Dust code base, there's one of Dust, was when it was developed as part of like an entire, bigger framework called the Kraken. It's back then, the main stack days, 2014, 2015, everything was cool around JavaScript. It's cool today, but it was cooler then. Maybe, I don't know, whatever. So what's happening is it wanted to be secure, this whole thing. So you see this like escape HTML. I'll zoom in a bit bigger so you can see it. It had, default escaping of all of those things. There's only one bug here, only one bug. Do your own code reviews. Look at it, see if you can find it. What's going on? Looks like if something is a string, it's going to test it out. It's going to, replace all of those single quote, whatever, less than, all of those instances of things like that into basically HTML entities, which is, what marked it before as well. So this all looks like it's good, right? It looks like it's okay. Except, what if something is not a string, right? What if it's not a string? Then we do not go inside this case. We return whatever string is brought to us without sanitizing it. Interesting. Well, when is this not a string? And this is my input. This is mobile. When is this not a string? If I do want to create, is that like a number? Or is this a string when the request parameters, whatever query object reads it on Express? What is it? I don't know. But I know a fact where I can actually influence this type to not be a string for sure. And that is anything on the comments? Not yet. Okay. But that is, I'm going to take this to the CLI so you can do it here. Go on. There we go. So let's try this. There we go. I'm going to try one request. Looks like it's, just doing its thing, nothing, precious going on here. You can try giving it different inputs. Again, not doing anything, out of the ordinary here. Consider request being served here. But what if I try representing device as an array, like giving it its brackets notation, and then I try to do some things? Well, first of all, nothing, again, out of the ordinary happening here, because this is just fine. But the moment I try to do different things, like maybe I kind of like, try to kind of like mess up with what's going on there. Oh, look at that. I am getting this error page, right? Syntax error, unexpected identifier. Object if, there's like a whole stack trace here, Liran Tal projects, repos, whatever. I can see, the server crashing here, whatever. This is not really working well for us. And we have understood now that there is an attack vector that we can do. So what if I had went in and did, well, I need to see the code, right? If I had went in and basically tried to escape, well, try to escape this if case. Because this if case, this is the helper that helps us basically do these kind of things. So you can see that this is a condition that we move over. And this helper is basically using eval, right? Eval on the server side to do evaluation of the condition itself. So at this point, what I could try and do is basically influence this by doing something else. I could try and maybe break out of, let's see if this works. break out basically of the eval statement by appending all of this, and then console log 1 runs. It doesn't run here. It doesn't run on the browser because this is all server-side evaluated. So it runs on the backend. So this is a way that I could actually do code injection on the backend based on the fact that this app is just using a vulnerable version of Dust. So all of this is happening basically due to this. Let's go back here. Hope you learned some new things here. So AppSec is challenging, right? Application security is challenging because why? Well, let me tell you why. This is the top 10 US computer science programs. And I stole this thing from like a DEF CON slide. Someone was showing this and he said, well, I'm now filtering this to all the universities or whatever the science programs, the CS programs that actually require that you pass an InfoSec training. What do you think? MIT, Stanford, go ahead. Which one stays on this list? 1, 2, 3. This is it. None, right? Because, well, AppSec is hard, right? There doesn't say that there are now not any InfoSec or AppSec trainings there, but these classes are not mandatory to basically finish off CS, which, as we know, like a lot of other things, like being, an expert on CSS, which I'd love to be able to do, but there's, this was not a mandatory skill for me to graduate university from. So I'm not. I suck at CSS, but whatever. So there's like a ton of AppSec related best practices in terms of different, Java, Spring Boot, whatever, Express, Angular, React, all on the Sneak blog. If you have any questions, I'd be happy to take them and help you code securely. So this was me, and back to you.
Let's see if we have any questions. Let me say, guys, yeah. Most of the time, developers write code they may not be aware has vulnerabilities. How, as a developer, I can avoid that?
Great question. Several ways. Linters. So this is just to frame the question. This is a question on first-party code, not using dependencies, which is a great question. So how can we write better code and not an insecure one? So one way is working towards best practices. Like Angular has this best practices security thing. Node has, if you read the documentation for like, the Node APIs, if you're using exec, it's bad, and it tells you, be careful. If you're using exec file, it's, a little bit better because you are reducing the attack surface and the attacker cannot control the executable. So many things. The other ways of doing this is, of course, linters. Like beyond the documentation, linters is a good, fast way. Not a really large ROI because it's a lot of noise and it's very rigid. You can't really tune it to what you need. The evolution on that is basically, beyond, code reviews, documentation, best practices, all of those things, beyond going into tooling. The next best thing are SAST, basically static application code analysis, which is something that reads the code, tries to understand what's a source, what's a sink, basically, what's an input from like a query param, going back into your, SQL injection or something, SQL query, and creating an SQL injection. So these are SAS tools. I actually have some of it here, like when I added my project. Sneak has this, we just released this, so this is like pretty new, but when you import the project, we basically, add it from GitHub or wherever you want. And at that point, we kind of like understand what's going on there. So code analysis is part of it, and it helps you find all of those issues. Like XSS, command injection in your app, and this is all in first-party code. This is my, if you scan the Goof app, which is what I use, which is open source, you could see it. So you could go and choose, whatever SaaS tools you want that work the way you want, and this is, the next best step to automate this process and help you fix those problems. Great question.
Amazing. So let's move on to the next questions because I see here you. Well, yeah, another question. Can you provide any reference for best security practice to avoid vulnerabilities? Oh, okay. Yeah, we've already done that. So you
cool,
can repeat that if you want. Any more questions from the crowd?
You're welcome to also ping me afterwards. Happy to chat.
Cool. So I don't think we have more questions. We just give you a round of applause. So
Thank
thank
you.
you very much, Liran. It was a pleasure to have you here.